Hi students, today we are going to see some numericals coming under relative lowering of vapor pressure. What do you mean by this relative lowering of vapor pressure? Actually it comes under colligative properties. What are colligative properties? These colligative properties, they depend upon the number of solute particles, okay? But these colligative properties, they do not depend upon the chemical nature of these solute particles, okay? But why this lowering of vapor pressure occurs? What happens? Actually, you just look at this picture. This container has pure solvent. Actually, what happens? This pure solvents will be getting vaporized easily, but when you are adding non-volatile solute particles, non-volatile, what do you mean non-volatile? Non-volatile means non-vaporizable. When non-volatile solute particles are added to this pure solvent, these non-volatile particles will be occupying the surface, okay? It will be occupying the surface of this solvent, so that this non-volatile solute particles will not allow this solvent molecules to evaporate easily. So automatically there will be a reduction in the vapor pressure of the pure solvent, okay? So this difference between the vapor pressure of the pure solvent and the vapor pressure of the solution is called as lowering of vapor pressure, okay? Lowering of vapor pressure. And what do you mean by relative lowering of vapor pressure? It's the ratio between the lowering of vapor pressure to that of the vapor pressure of the pure solvent. This is relative lowering of vapor pressure. Understood, students? This P0 represents the vapor pressure of the pure solvent and P represents the vapor pressure of the solution. Okay. Next we are going to see the formulas we are going to utilize in these numericals, right? See the formula, students. Actually, Raoult's law, it relates the relative lowering of vapor pressure with the mole fraction of the solute. Actually, two types of Raoult's law are there. Raoult's law which deals with non-volatile solute and the Raoult's law which deals with volatile solute. Okay, volatile means vaporizable solute. See, here comes the first one, Raoult's law that deals with non-volatile solute. Actually, Raoult's relative lowering of vapor pressure of an ideal solution. This is relative lowering of vapor pressure of an ideal solution containing a non-volatile solute is equal to the mole fraction of the solute. Okay, see mole fraction. Here we know that is P0 is the vapor pressure of the pure solvent and P is the vapor pressure of the solution. Then how to calculate this? What is this mole fraction? How to calculate mole fraction of the solute? See, mole fraction of the solute is equal to number of moles of the solute divided by number of moles of solute plus number of moles of solvent. But here we will be ignoring this number of moles of solute because when you are comparing with the solute and the solvent molecules will be more. So we will be ignoring since it is infinitesimally small in size, right? So we will be having this alone, N2 divided by N1. How to calculate N2? See, N2 is equal to W2 by M2. What is W2? It is the weight of the solute and M2 is the molecular weight of the solute. And how to calculate N1? See, W1 divided by M1. What is N1? It is the number of moles of the solvent. So, W1 is weight of the solvent and M1 is molecular weight of the solvent. So, when you are using this one, that is X solute is equal to N2 by N1, and when you are substituting these two values W2 by M2 and W1 by M1, you will get this formula. So, relative lowering of vapor pressure P0 minus P by P0 is equal to W2 into M1 by M2 into W1. Okay, this is the formula. And next comes the formula which deals with the volatile solute. Here, the partial vapor pressure of a component in a solution will be equal to the product of the vapor pressure of the pure solvent and its mole fraction. Understood? For example, if you are having two components A and B, see the partial vapor pressure of A will be equal to the partial vapor pressure of the pure solvent A into its mole fraction. Okay, likewise for B. If you want to calculate the total vapor pressure, total pressure of the solution, then we can sum up these two partial vapor pressures. PT is equal to PA plus PB. Understood, students? So these are the two formulas. Here this is one formula and this is another formula. We'll see the numericals now. The problem, students, what weight of sucrose, its molecular weight has been given 342, should be added to 1800 grams of water at 30 degrees centigrade to lower its vapor pressure by 0.001 mmHg. The vapor pressure of water at 30 degrees centigrade is 18 mmHg. See, they are asking you to calculate the weight of sucrose, that is they are asking you to calculate W2, weight of the solute, okay, and but the molecular weight of the solute is given, and then weight of the solvent is also given. Solvent is water, and the lowering of vapor pressure, that is P0 minus P, is also given, that is 0.001 mmHg. And then what else is given? This P0 is also given, okay, 18 mmHg, that is vapor pressure of water, that is pure solvent, is also given. So let us write the data first, then we'll come to the problem. So W1, what is W1? It is 1800 grams, okay, and next P0 is equal to 18 mmHg, okay, and then what else is given? P0 minus P, that is lowering of vapor pressure, is given, that is equal to 0.001, and then M2 is also given, that is 342. And then M1, we are in need of M1. What is M1? See, water is the solvent. So we are in need of the molecular mass of water. We can calculate the molecular mass of water from its atomic mass of all the elements. By summing up the atomic mass of the hydrogen and oxygen, it is possible to calculate the molecular mass. So thereby its value is 18, okay, and you are asked to calculate W2. Now write down the formula, students. P0 minus P by P0 is equal to W2 by M2 into M1 divided by W1. Substitute all the values. What is P0 minus P? 0.001 divided by 18. Is it not? 18 mmHg. P0 value is 18. That is equal to, what is W2? We want to calculate. Is it not? M2, what is M2? It is 342. 342 into M1, 18. W1, what is W1? 1800. Okay, now simplify. You can bring W2 this side. W2 is equal to 0.001 into 100 into 342 divided by 18. What's the answer, students? It is 1.9 grams. Okay, so this is the answer. Hope you might have understood. We'll see the next problem now. Read the problem, students. The vapor pressure of pure toluene at certain temperature is 300 mmHg. That means P0 is 300 mmHg. Okay, and at the same temperature, the vapor pressure of the solution containing 3 grams of non-volatile solid in 87 grams of toluene is 290 mmHg. That means they have given P value also, and 3 grams of non-volatile solute means W2 they have given, and 87 grams of toluene, that is W1, is also given. They are asking you to calculate the molecular weight of the solid. That means they are asking you to calculate the molecular weight of the solute. Understood, students? First let us write the data. So what are the data given? W2, what is W2? It is 3 grams. Okay, and then W1 is also given, that is 87 grams. Okay, and then M1 is M1. What is M1? What is the solvent used? It is toluene, right? What is the formula for toluene? C6H5CH3. See, by adding up all the atomic weights of all these elements, it is possible to calculate the molecular mass. Okay, how many carbon atoms are there? 6 plus 1, 7. So 7 carbon atoms are there. What is the atomic weight of carbon? It is 12. So we will have 84. When you are summing up, you will be getting 84. And then how many hydrogen atoms are there? 8 hydrogen atoms. What is the atomic mass of hydrogen? 1. So 8. What is the total amount? 92. So the molecular mass of the solvent toluene is 92. So it is 92. Understood? Then P0. What is P0 value? It is 300 mmHg it's given. And then the vapor pressure of the solution is 290. and they are asking you to calculate M2. Okay, molecular mass they are asking you to calculate. Now we shall write the formula. P0 minus P by P0 is equal to, what's the formula, students? W2 by M2 into M1 divided by W1. Okay, now substitute all the values. What is P0 minus P? P0 is 300 minus 290 divided by P0 value, it is 300. Okay, is equal to, what is W2? 3 divided by M2 we want to calculate, then M1 is 92 divided by 87. Is it not? W1 is 87. Now we can simplify this. So 300 minus 290 is 10 divided by 300 is equal to 276 divided by M2 into 87, and we are in need of M2, is it not? So we shall bring M2 this side. So 276 into 300 divided by 10 into 87. Okay, so the value is 8200 divided by 870. So the answer is 95.17. What's the unit for the molecular mass? It's gram per mole. Okay, so I hope you might have understood. We shall see the next problem. Read the problem, students. Methanol and ethanol forms a nearly ideal solution at 300 Kelvin. A solution is made by mixing 32 grams of methanol and 23 grams of ethanol at 300 Kelvin. Calculate the partial pressure of its constituents and the total pressure of the solution. At 300 Kelvin, the pressure of methanol is 80 mmHg and pressure of ethanol, that is ethanol, pure ethanol, is 50 mmHg. See here, they are asking you to calculate the partial pressures of the constituents. Two constituents are given, that is methanol and ethanol. Okay, and the pure methanol value is given and pure ethanol value is also given, and the amount of methanol dissolved and ethanol dissolved is also given. Okay, and you are asked to calculate the partial pressure. So let me write the data given first. Weight of methanol, I am going to give WMS, weight of methanol is equal to 32 grams, and then weight of ethanol is also given, and that is 23 grams. Okay, and the pressure, vapor pressure of methanol, pure methanol is given, that is 80 mmHg. Okay, and what else is given? The vapor pressure of ethanol, that is pure ethanol, is given, that is 50 mmHg. Okay, and you are asked to calculate PM, that is partial vapor pressure of methanol, partial vapor pressure of ethanol, and also total pressure. Okay, for this problem you should make use of the second formula which we saw earlier, that is Raoult's law, which deals with the volatile solutes. Understood? Methanol and ethanol both are volatile in nature, so we should make use of that formula, right? So we can make use of this one. So how to, let us write the solution, right? PM, that is partial vapor pressure of methanol, is equal to the vapor pressure of methanol in pure state into the mole fraction of methanol. Okay, and the next formula is the partial vapor pressure of ethanol is equal to the vapor pressure of ethanol in the pure state with the mole fraction of ethanol. And how to calculate the total pressure? Total pressure is equal to PEM plus PE. Okay, so these are the formulas. Now we should substitute all the values and find out the answer. Okay, students, we shall find out. But see, we are having P0M we are having, is it not? P0M we are having, P0E also we are having, but we don't have this one, XM and XE. How to calculate NM? NM is equal to weight of methanol divided by molecular weight of methanol. Okay, molecular weight of methanol. What is the weight of methanol given? It is 32, right? What is the molecular mass of methanol? That we want to find out. What is the formula for methanol CH3? OH. So by summing up the atomic mass of all these elements, it is possible to calculate the molecular mass of methanol, that is 32. Okay, so 32. Again here we want to substitute 32. So the value, Nm value is 1. Okay, now we want to calculate for Ne, that is Ne, number of moles of ethanol is equal to weight of ethanol divided by molecular mass of ethanol. Okay, what is weight of ethanol? Tell me. 23. What is the molecular mass of ethanol? Here what is the formula for ethanol? C2H5OH. Okay, you just sum up all the atomic masses of all these elements and your answer would be, that is molecular mass of ethanol will be 46. Okay, so now 23 divided by 46, the answer is 0.5. Understood, students? Now it is possible to calculate the mole fraction of methanol. So mole fraction of methanol, see we should, I use this formula, Xm is equal to Nm divided by Ne. Okay, so Ne plus what is Nm plus Ne plus Nm. Understood? So number of moles of the solute divided by number of moles of solute plus solvent, like this is the formula, right? Two components also you should, both the components you should give in the denominator. So Xm is equal to, what is Nm value? It is 1. 1 divided by, what is Nm? 1 plus what is Ne? It is 0.5. 0.5. So Xm is equal to 0.1 by, that is 1 by 1.5, that is equal to 0.666. Okay, likewise you want to calculate for Xe also. How to calculate for Xe? Ne divided by Ne plus Nm. So what is Ne value? Ne value is 0.5, right? 0.5 divided by 1.5, that is equal to 0.333. Okay, so we have found out Xm and Xe. Now it is possible to calculate these two. Pm we can calculate, Pe we can calculate, Pt is also easy. So how to calculate Pm? Pm is equal to P0 value. What is P0 value? P0 value for methanol, it is 80. Okay, 80 into 0.666. 80 into Xm, is and Xm value is 0.66. So the answer is 53.28. Okay, mmHg. Right, likewise you should calculate for ethanol also. Ethanol value, P0 value is 50 and Xe value is 0.333. What is the answer, students? It is 16.6. Okay, now we shall calculate Pt. How to calculate Pt? Pm plus Pe, is it not? So Pm value is 53.28 and Pe value is 16.6. So the answer is 69.88 mmHg. Hope you might have understood, students. We shall see the next problem. Read the problem, students. What will be the vapor pressure of a solution containing 3 moles of glucose in 1 kilogram of water if the vapor pressure of pure water is 4.57 mmHg? See here the vapor pressure, that is P0 value is given. Okay, and 1 kilogram of water, that is W1 is also given. And then number of moles, that is N2 is also given. Okay, and you are asked to calculate the vapor pressure of the solution. Alright, so they are asking you to calculate P value. So we will write the data first. Number of moles of glucose, number of moles of glucose, that is N2 is equal to 3. Okay, mass of solvent, that is W1 is equal to 1 kilogram. So we can convert this 1 kilogram to grams, that is 1000 grams. Understood, students? And then P0 value is also given. P0 value, it is 4.57 mmHg. Okay, and you are asked to calculate P value, right? So we shall, according to Raoult's law, okay, according to Raoult's law, see P0, what is the formula? P0 minus P by P0 is equal to N2 divided by N2 plus N1. Okay, So here we have N2 we are having, P0 values also we are having, but we are in need of this P, okay, this value we want to calculate. And look at this one, we are having number of moles of the solute, N2 is there, but we do not know N1. How to calculate N1? So we want to calculate N1, that is number of moles of water, okay. How to calculate number of moles of the solvent? N1 is equal to W1 divided by M1, okay, that is weight of the solvent divided by molecular mass of the solvent. Weight of the solvent is given, right, 1000. But what about the molecular mass? Molecular mass we do not know, but we know the solvent, right, water H2O. So it's possible to calculate the molecular mass of water if you know the atomic mass of all these elements, and the molecular mass is 18. If you are summing up the atomic mass of all these elements, you will get the molecular mass. So it is 18. So what is the answer? It is 55.5. So number of moles of water is 55.5, that is solvent is 55.5. Now substitute all the values. What is P0? 4.57 minus P divided by 4.57 is equal to 3, is it not? N2 is 3 divided by 3 plus 55.5. Okay, now we shall bring this 4.57 this side. So 4.57 minus P is equal to 4.57 into 3 divided by 58.5. Okay, that's equal to 0.234. Now we are in need of this P, right? So P, we shall bring this value this side. So 4.57 minus 0.234, that is equal to 4.336 mmHg. Hope you might have understood all the problems, students. This is Sanita Raj, your chemistry mentor, signing off. We shall see in the next session with the next set of problems.